Hi everyone, welcome to the Machine Learning Digest Weekly, and today we are going to be looking at week 9, which is the week of February 26th and March 4th. All of the major news articles, research papers, any industry news that we observed. So let's go to the first one this week. Now this article is from, this research paper is from Meta AI, and it talks about the LLaMA, which is an open and efficient foundation language model that has been developed by the Meta AI company. Now, this is a set of open source models from Meta that can perform optimally at different budgets. They have built 4 different models, which are ranging from 7 billion parameters to 65 billion parameters. So which is roughly 10 times smaller than the OpenAI GPT-3 models. As you're aware, the GPT-3 models are approximately 175 billion parameters. Now, what they have tried to do is they've tried to democratize AI and distribute it under a non-commercial license so that anybody can use it, any researcher can use it. And it also runs on a single CPU, right? So the data sources that they have taken to build these models include the English CCNet, the GitHubs, Wikipedia, different books, the ArcXIV, and the Stack Exchange. And this has been tested on different benchmarks like the Boole IQ, the Win Grande, OpenBook QA, Natural Questions, Real Toxicity Prompts, and the Winnow Gender. And it has been found that the LLaMA 13, which is the second smallest model, like we said, the smallest model is based on 7 billion parameters. LLaMA 13 is based on 13 billion parameters. This is the second smallest model. Even this outperforms the GPT-3 on most benchmarks, right? And when we talk about the biggest model, the 65 billion parameters LLaMA model, now that is competitive with some of the best models like the DeepMind's Chinchilla model and the Google Palm model. And the Google Palm model is built on 540 billion parameters. So the LLaMA 65 is very competitive to even the Google Palm model. Okay, so the next paper is on deep reinforcement learning for cyber system defense under dynamic adversarial uncertainties. Now this sounds like a mouthful, but let's look at what the paper is all about. Let's look at the problem statement first. The problem statement is that now creating an autonomous cyber defense strategies and action recommendations is hard because it incorporates the dynamics between the attackers and the defenders, and also the uncertainties that are associated between the attackers and the defenders, right? So it's a very hard problem to solve. Now, the researchers at the Department of Energy, the Pacific Northwest Laboratory, have created this paper and the underlying models. Now, what they've done is they have trained an AI system using deep reinforcement learning. Now, that can respond to attackers in a customized simulated environments, right? Now, what they've done is they have trained 4 different deep reinforcement learning neural networks, which are based on maximizing the rewards. And how they maximize the rewards is by avoiding the compromises and by reducing the network disruption. Now, what they've done is they've used this OpenAI Gym toolkit, and the entities is for the attackers is based on a subset of 15 different techniques and 7 different tactics from the open source famous AI framework, cybersecurity framework called the MITRE attack framework. Now, the objective is that they have to go through 7 different attack chains until they reach the final stage, which is the impact and the exfiltration stage. And the company claims that they are able to stop approximately 95% of the attacks that are happening in the simulated environment. So let's look at the next article. Now this is about optical transformers, and the research paper talks about running a transformer model in an optical network. Now, that is pretty interesting, So the problem is that the transformer models, as you're aware, it consists of many millions to billions of parameters that it has been trained on. Now these have very high energy consumptions and very high latency. right? And we also know that the optical networks, they provide a much better efficiency, they provide a lower latency and much lower cost that comes with the analog computing. Now, what they tried to do in this paper was they tried to run these transformer models through optical networks, and then they came out with a summary of findings, and I'm going to be discussing those findings with you. The first one is that the linear operations in the transformers could be accurately conducted in a real optical hardware despite the error and the noise that comes with an analog computing, right? The second summary is that the energy consumption was orders of magnitude lower than even the most cutting edge processors that they have. So that claim that they had made that they can cut down the energy consumption was found to be indeed true. And then they found that this may be a viable solution for running large-scale linear transformer models. Now, I would recommend you to go through these papers. The link is in the description below. It will give you a lot of people who are interested in optical networks. It will tell you a lot about how artificial intelligence and particularly transformer models could be run in an optical network. Okay, the next article is on a high performance speech neuroprosthesis, which is essentially a brain computer interface. Now, this is the problem statement which is solving here is this a person who has got speech disorders or who has lost the ability to utter clear words. Now, Stanford developed a brain-computer interface, which is by using a person who had paralysis. By using this brain-computer interface, can convey his thoughts and can communicate at approximately 62 words per minute. Now, what the system does is it uses the recurrent neural networks, which are capable of synthesizing speech signals that are found in a patient's brain. Implant intercortical microelectrode arrays are implanted in a patient's brain, and these arrays record signals at a single neuron's resolution, and then they pass on these signals to the recurrent neural network, which is implemented as a gated recurrent unit, GRU, and that GRU essentially is the one that decodes the speech. Now, they have found error rates of 9.1%, which is pretty significant. Okay, so the next article is about computer vision, and it's about this paper called RealFusion, which is a 360 degrees reconstruction of any object from a single image. Now, the problem statement is that the off-the-shelf diffusion models that are there, they are only trained on 2D images, two-dimensional images, and they have no special supervision for 3D reconstruction. Now, what the researchers from Oxford University did was they created a very special diffusion model and they called it as RealFusion. Now, this diffusion model is capable of reconstructing different objects from a single image. It uses the CO3D dataset, and it uses a concept called as neural radiance to extract the 3D information from an image. It also incorporates an additional regularizer to smoothen out the reconstructed surface that it creates. And the resulting method has been extremely successful in creating plausible 3D reconstructions of objects that have been captured in the wild. Hi everyone, the next article is from MarkTech Post, and this is dated March 1st, and this talks about the unlocking secrets of deep learning with Tensorleap's explainability platform. Now, the problem that we're trying to solve here is that the deep learning explainability, as we know, is quite inadequate, particularly in the presence of unrepresented samples or categories. Right? Now, tools like DeepLift, which is deep learning important features, and LLaMA, which is the ML model inspection and interpretation tool. Now, these are some of the tools that are available for the deep learning interpretability. but they are computationally expensive, and it just focuses on local explainability. What Tensorleap has done is that it can troubleshoot, debug, and visualize a neural network. And it also can visualize that how a neural network perceives data. It parses computational graphs and tracks every single sample. Now what the tool does, it provides a population visualization, as you can see on the left hand side here. It provides deep unit testing, and it provides a guided error analysis. Now the Tensorleap population analysis, when it finds that there are certain samples in the data that have resulted in errors, it can recommend you to remove those erroneous data that is there. It will even point out where the erroneous data lies. It also creates, the deep unit testing allows the creation of multiple unit tests which are based on model features and samples. It conducts unsupervised machine learnings to identify potential clusters or abnormalities in the model features and data. Now this provides, and Tensorleap provides, an easy way to identify and fix errors in a model, to visualize where the network error lies, and automatically detect features. Hey guys, so the next on is Tracer. Now this is an article, a research paper from DeepMind, and Tracer is a compiled transformers as a laboratory for interpretability. Now what this means is, the problem that we are trying to solve here is that currently the methods that are for producing transformer explanation or explainability or interpretability are limited, right? So what DeepMind has done is they have proposed an architecture called Tracer, now which is an acronym for Transformer Compiler for RASP. Now what this does is, this compiler does is, it compiles human readable code into weights for a neural network. And this directly addresses the problems of insufficient ground truth explanations. Now, how this compiler converts the human readable code into weights is using this concept called as restricted access sequence processing, or RASP. Now that is a domain specific programming language for the transformer computations. So it uses this language to convert the human readable code into weights. And this can only be used for the standard transformer decoder models like GPT-like architecture, right? Now the Tracer can be used as a tool for accessing the model interpretability, or for substituting the part of the models using these hardcode weights that it has programmed. Now this is assumed to increase the model performance greatly. Hi everyone, let's look at the next article. Now this is called Composer, Creative and Controllable Image Synthesis with Composable Conditions. Now the problem here we are trying to solve is that most of the text to image models, when they are applied to real world applications, the designers always feel that they have limited control. They always want more control in terms of semantics, form, color, or style. Now this composer has been introduced by Alibaba. Now it's a 5 billion parameter controllable diffusion model that has been trained on billions of text and images pairs. And it uses multi-diffusion model, which with a UNet backbone. That is how the composer is implemented. Now what it does, it smoothly reassembles the various visceral elements to create new pictures, and that's why it's called a composer. And it works in two stages. In the first stage, in the decomposition phase, the algorithm, that is the computer vision algorithm, it breaks down the images into their individual representations. And in the second phase, which is the composition phase, the composer reconstructs the images from each of these broken down representation subsets. So that is how the composer works. Okay, so let's look at the next paper, research paper. Now this is titled Prime QA, the prime repository for state-of-the-art multilingual question answering research and development. Now, Prime QA is an open source library that has been designed by the QA researchers and developers to easily facilitate reproducibility and reusability. Now, this has been developed by IBM Research AI. This is an end-to-end toolbox that has got pre-trained models, and those pre-trained models are for retrievers and for readers. It's been built on top of the open source NLP libraries and provide Python scripts, simple Python scripts, as entry point to the core components which are there in the back end. The tasks that these models are used for include retrieval, which is search, reading comprehension, question generation, question answers, and many others. Hi everyone, so let's look at the next research paper. Now the title of this paper is Enabling Conversational Interaction with Mobile UI Using Large Language Models. Now so the problem we are trying to solve here is that there are multiple pre-trained task-specific language models that are there and that are needed to perform diverse UI tasks. When you talk about natural language, right? Now, this paper, which is coming from Google Research and University of Toronto in Canada, now this examines the feasibility of enabling versatile conversational interactions with the mobile UI using a single LLM. So as opposed to multiple task-specific language models, here the paper examines using one single large language model that will perform the conversational interactions with the mobile UI. Now, this paper also provides a lightweight and a generalizable approach to enable the language-based mobile interaction. And it focuses on 4 key UI modeling tasks, and that includes the screen question generation, screen summarization, screen question answering, and mapping the instructions to the UI action. And last but not the least, the paper also discusses prompting techniques for adapting the LLMs to the model UI. Hey guys, so this is the last article of today. Now the title of this article is Chain of Hindsight Aligns Language Models with Feedback. Now this article or the paper is from the University of Berkeley, California. Now this allows the language models to learn from any form of feedback. The problem statement is that the reinforcement learning with human feedback, RLFH, now this, which works on a reward function basis, it is very challenging to optimize such models. Right now, under the technique that is proposed by the university, all the feedback that is being forwarded to this model is being converted into sentences, and that feedback is then being used to fine-tune the model to understand that feedback, and that is called the chain of hindsight. Now, the chain of hindsight, what it does, it randomly selects one or more of the model output during the training and uses that output to construct a sentence using both the positive and the negative feedback. And on the tasks that are summarization and the dialogue tasks, it was found that the COH models, they outperform all baseline models that are using the supervised fine-tuning or the RLHF. So that's a wrap. Thank you very much. We'll catch you again next week. Stay tuned.